All right, so let's kick this off. So we've got a technical glitch. Not everybody is able to join. We're going to record this. This session's being recorded. Those that are here, feel free to drop a question in the chat. We'll stick around for a bit afterwards for a Q&A if anybody would like to discuss anything. To those that were able to get in, thanks for attending. Thanks for registering for the on-machine solutions design and optimization webinar featuring the Armor PowerFlex. We have John Zekris, the Drive and MCC product manager. We have Austin Malhado, Drive and MCC product specialist. These guys know everything there is to know about this stuff. So been looking forward to this. Yeah, and without further ado, John, Austin, feel free to take it away.
Hey guys, I'll start off the presentation, wave my hand. Austin, wave your hand. You see us on the slides there on the first page there. And we'll shut off our cameras now too. So just to let you know what we look like and when we come see you, all that great stuff. Yeah, so today we're presenting on this 22nd day of February 2023 on machine solutions design optimization featuring the new Armor PowerFlex drive. We've had devices and products called Armor Starts of different flavors throughout the past decade or so, and certainly there's a new product that Rockwell and Gary are very excited about. So there's a picture of our first slide from the Rockwell slide deck. So what is on-machine? On-machine is a centralized design going over to a distributed design architecture. So traditionally, we've had conveyor lines and long process lines and things within it. Goes several hundreds of feet and things like that. So you have a central panel with controller system, safety systems, motor control, contactors, VFDs, soft starters, and items like that. And then you'd have basically long cable runs to all the different parts of, say, a conveyor system, which this product we're going to talk about is pretty popular for. So your VFDs and all contactors and other ideas starters would be inside the same main panel. I mean, you may have some distributed panels, but again, centralized multi-door freestanding or wall-mounted panels with a few items mounted in it, or a lot of items mounted in it, and then some cable runs out to the different parts for the motor loads and all that, right? So it can be a complex design, long wires, a lot of connections manually, hard wiring back and forth from end to end. Certainly chance for a lot of errors from wiring and other parts of installation errors that can happen. A lot of installation costs and a lot of time consuming things that will happen for putting the whole system together. Certainly the distributed design, you can have a much smaller footprint main panel, mainly sourcing power, possibly controller and items like that. And then you can put out to your conveyance lines, certainly more distributed items. So on the right-hand side is a little graphic here where we're starting to put now motor controls on the machine, more out where the conveyor parts for the different motor loads for different segments of conveyor that you want to run your motor control from. So, and a lot more VFDs are being installed nowadays. And certainly, basically, so a lot more control precisely over the speed and the process control that's happening with VFDs. And now we have this more on-machine solutions we've been seeing a lot more lately that can make connectivity and change-out ability a lot easier. So certainly the mean time to repair, like when something goes down, if you have, obviously you'd want to have spares, you can switch out that on-machine product pretty simply, a lot of quick connections and things like that that can happen. Definitely the reduced installation time and efficiency of getting the system up and running is an important part. So in their centralized material handling solution, certainly pretty much mention all this. So you can see in those little circles some pictures like a big panel, large dedicated footprint, whether it's in a motor control room or along the plant floor. You'd see on mezzanines or within the floor on the main level, you'll see large panels and multi-door panels along the way. A lot more going on for wiring and complexity of the connections, and doing a lot of manual connections, a lot of testing and things you'll have to do along the way. Certainly a larger schedule and all that to put the whole system together. So definitely it adds to the project cost. Certainly, you know, the individual devices are priced at what they are, so they'll be a little lower than an on-machine packaged little product, but certainly all the other stuff that goes along with it that could really increase your project cost. Something you'll have to weigh between the two different solutions to evaluate if an on-machine solution is good for you. And certainly with the quick connect design, on-machine solutions can, with the quick connectivity of the power and all the I/O and the network connections, watertight, waterproof, dustproof kind of connections, and they just plug in a certain way. There's less chance for errors if you have a quick connect on both ends. Sometimes you'll have some pigtail wiring ends on your main panel side for different things once in a while, like maybe introducing power to the system in the first time. So that'll be just some wires that are like loose like that. But it's definitely a scalable design. You can make changes and add to the system along the way pretty easily. So if you're putting a second conveyor line in, or something like a diverter where you go from this conveyor to that conveyor for different scenarios and you're adding to the system, you can just like add these on-machine drives along the way and just use the connection system to put it all together. Smaller footprints, smaller motor control cabinets, getting everything more close to the point of operation is a good thing. And you can diagnose and replace, and having less specialized people that can be involved to make the switch out because of the quick connectivity of the on-machine solutions. So you can have a total decreased cost on that, and you can reduce your installation cost by an average of about 30% or more with the on-machine, as Rockwell has done the analysis before with customers and with themselves doing work through that. So you got a lot more flexibility in that scenario there. So here's a little picture we wanted to throw in for an on-machine. So you have like cabinets, say on the right side, you have your HMI, right side panel, some console that's sitting there with that red button. So you see my mouse coming over here. So there's traditional thing. This is like a little engine manufacturing line, as you can see. And along the way on your conveyor, this is a like kind of compact for the photograph here. You'd have different on-machine solutions and connectivity of I/O and safety systems. You'd have a controller that can also go on machine and be all washed down and dust tight, dust proof. And all the connectivity you can see between networks and I/O sensors plugging in. And obviously the product that we're going to be talking about in this presentation today, the Armor PowerFlex. So our little VFD would be in a washdown solution drive that sits right on the side of the conveyor and is close to the motor. So a small little connection to the motor, maybe accessories like dynamic brakes that can quickly connect. And again, the network and all the I/O points can connect to there. And again, just really reducing the amount of time and labor that's involved with trying to wire this all up manually. And even when you're doing a network solution, which is generally pretty good, a lot less going on for just a lot of things for power and wiring. So the Armor PowerFlex VFD, a summary quickly before we get into things here. We have integrated safety and hardware safety in a single catalog string when you're buying the unit. So we have the ability to do traditional hardwired safety and integrate safety, which is SIP safety over Ethernet, and general comms for information collecting and control of the device, all on the same Ethernet connection. Smart, we have premium integration with Studio 5000. So just like a VFD, We have drive profiles you can add to your project under the Ethernet network. You have the ability to now set up the tags generated for you, collect information, and do control over the drive with the tags generated for you, and make things a lot simpler for having a profile to look at status of the drive, information about the drive, and do the control. And security, the SIP security is part of your defense and depth strategy. That's now enabled in this drive for more network security and device security for any unwanted persons and entities trying to get into your network and do some damage and wreak any havoc. Flexible, seamless user experience from 1 to 20 horsepower. So throughout the next months and year, there'll be more and more releases of bigger frame size of these drives. So the hardware feature summary. So definitely it's a 4/12 enclosure, IP66 with hygienic friendly design, so it can go into your food processing plants, food and beverage, pharmaceuticals also. Embedded, discrete, and safety I/O. So the connections you'll see on the face there on the left. Encoder input. It can do a good temperature range of -25 to 55 C. There might be some derating, obviously, on the hotter end, past about 40 C. Typically, you'll have to derate most devices, such as drives. Shock and vibration, good ratings. It's obviously a one-box design for everything there for you. The local disconnect, great rating for 100 kA short circuit current rating at 480 volt. And by the way, this is a 480 volt only solution at this point. So it's generally, with our popularity of the type of plants that we see here in Ontario, and obviously the American market and European markets that would use that voltage class. Definitely the connectivity for power and accessories that you can mount, and we'll talk about that more later. And there's nothing to do to take it apart and work on it, so it's just the swap out of the whole unit when you, if this unit happens to go down, then you want to swap it out. You would just have another whole unit spare, or have a few on hand spare, depending on the count of how many of these devices you would have for each power size. And it would be a good idea for quick change out, and then you can get it later, possibly repaired with Rockwell. We'd have to get into that, back to you on that if you have any questions on repairability and exchanges programs. Software side of things, again, as mentioned before, Ethernet IP enabled. This would be a device you would pretty much go on Ethernet. I don't think you just hardwire it at all. Like I said, there's a lot of support for I/O on there, so you can have these. It's dual port, embedded 1,000 megabits per second switch that's on board. You can have static or dynamic IP address, so the IP address can be served up by the switch, or you can have just hard static addressing. Add-on profiles, as I mentioned before. Setup wizard, so you can do startup wizard for drive startup, just the same as our individual drives, whether it's a PowerFlex 525 or 750 series. Automatic device configuration, and we'll talk about that. I have a little bit of an animated slide for that. Short form for that is ADC. And it supports the firmware supervisor within a Logix controller. So we can automatically get the right firmware exactly flashed, and that'll tie in nicely to pharmaceutical, where they always want to have everything the same, and things are approved at the right levels for firmware and hardware type stuff. Real-time data that supports analytics. Events with a real-time clock. You got one firmware file, one add-on profile file, and troubleshooting snapshots. So you have a lot of capabilities when it's integrated within Ethernet back to our Logix controllers for controlling information, and it's definitely a present and future product for you. Sustainability features, economizer mode and sensors vector, so you'll be able to adjust current output to help and reduce energy costs when you're running with energy data monitoring and reporting capability. So we're starting to see that feature now in our drives. So when things are not working as hard, you certainly can run at a little bit more of a reduced energy and a little more efficiency there. SIP energy is information we can pull back from the device back into our control system and with our software systems that we have is available. And we can see a lot more that's going on for what's going on with the different loads within your system to monitor energy and have your plant running as efficiently as possible to manage your cost on energy, whether you're getting hit with demand charges or how machines run. You certainly enhance your ability to collect that data and work with it. Certainly, less wire and cable is a good thing. Less copper, less insulation, less materials that are involved. Whether it's stripping the ends of wires and just flicking them off and then just putting them into a garbage and all that. So the cables are made for you. They're all quick connect. It's a hardened design for withstanding some shock and vibration, harsh environments. It's wash down, dust proof. And certainly, even in a centralized panel design, you may have dust, contaminants, and problems that can get into your main panel that can cause havoc on VFD drives that could be problematic. And there's a lot of drives in the same location. There could be a lot of things that go on. So certainly, these are mounted along the line and are designed to not have a problem with really anything. Okay, so for now, we currently have right now frame A available. It goes up to 3 horsepower, so 1, 2, and 3 horsepower, being 380 to 480 volt input range. So it handles all the European and American markets and any plants that choose to be 480 volt within Canada. And the whole set of frame A accessories shaded out here. We have frame B coming out in the next few months, and certainly over towards within the next year. In this environment, things are not always perfectly on time for release. So those are now in development for extended horsepower past 10 horsepower to the 15 to 20. And with frame B, I mentioned would be a 5 to 10 horsepower range. So over the old Armor starts, we have a much more increased horsepower size that would be planned in this product line. So definitely a much larger range of this on-machine long process or conveyance lines that we can handle and kind of have the same style product cover you for the whole scenario there. There's a picture of the frame A drive. Just everything from everything you see there from the quick connects, the disconnect, and the connections, the heatsink, the design, and the connections on the bottom. Frame B, you'll start to see just a little bit of a difference. There's a heatsink fan mounted on the front. That's obviously good for the environments that it's going to be sitting in. A little bit different placement of some of the devices like the disconnect. Just getting a little bit bigger to cover that horsepower range. Frame C is in development, so we don't have a picture of that one right now. There's some variants. There would be a functional safety variant and a standard variant within the part numbers. The bulletin numbers like part number catalog strings 35S and then 35E. And certainly everything's about the same in the horsepower ranges. So, and then now details on what you'll get within each variant. So functional safety variant, integrated hardware, hardwired and network safety, safe torque off for advanced safety. You get some IOs there for safety, user IOs, runs AC junction motor, encoder input, local manual control, and the disconnect and network status LEDs and statuses. The standard variant will be available just so if you have no safety need for that, certainly you'll just see mainly the safety is taken out of the equation there. So if you just want a standard on-machine drive, that'd be fine also. More than likely, you're going to see safety variant is the one that everybody would be going for a lot more on that. So here's the functionality of integrated hardware safety all in one device. So we have the advanced safety, so safe torque off, safe speed monitoring, safe brake control, those kinds of like acronyms there, starting with the S there. So network safety plus IO, and then hardware safety is mainly just down to safe torque off and safe speed. And then we have a rating of SIL 2, performance level D, to SIL 3, class 3, performance level E, category 4. And obviously the capabilities and the functionality they can enable within the device will be based on all the safety risk assessments and things that you'll be going through with your engineering contacts hired for the project. Okay, so here's a little animation on ADC, automatic device configuration. These are in a lot of our newer products, standalone VFD drives. So on the slide here, we have a Logix controller, Stratix switch, everything's networked together to all your PowerFlex, Armor PowerFlex along the line. So it's a network, it's the field devices and the controller as a whole integrated system. Things are enabled in the controller. Things can be enabled in the switch also. Traditionally with automatic device configuration, you could hard program. If you're doing like daisy chaining a network, you would have to hard program the on a traditional drive and things like that on the keypad, or power up the drive ahead of time, use software to set the IP address. So you can kind of get it on the system. And that's no different here if you're not somehow using the Stratix switch, but it's a great system to have the switch in place. And if you want to serve up IP addresses with HTTP server kind of basically within that switch, everything could be done for you. So you would basically be able to have if you have a situation where one of these Armor PowerFlexes goes down, you don't need a very well-trained technician to make the changeout, because the controller will do a lot for you and can set everything for you and get the parameters into the device. So I'll just, as I click the mouse here, you'll see each stage. So everything's running there. You see the spinning little motors below the devices. Something happens, one goes bad, it gets changed out. So your technician who's good at midnight shift, right? They're not as those project style technicians during the day who are more trained up on everything, software and everything else, will come and make the change out of the device. So a new one goes in, the switch will send the IP address down to the device, and then the configuration would go from the controller. So that's your parameters for the drive, for all the settings of how it runs with accel time, decel time, maximum speed, settings, the motor nameplate data loaded in, the tuning and all that stuff will now come down from the controller down to the device, and now it's back up and running again. So it kind of was animated just kind of a little bit faster for the last few steps. We go back through it again. IP gets sent down, the configuration, that's parameter settings go down, and if needed be, the firmware could get set up or down from what you got shipped or spares sitting on your shelf, and you would have that even set for you with firmware supervisor as needed. That's another feature that can be done. So firmwares can be loaded onto the controller, and the right devices would have the right firmwares. So it's more important in pharmaceutical for sure for that kind of stuff. So that's about it. I think it's Austin's turn now to come up, and let him just quickly talk about himself, and then take it from here to the end. And we'll have questions a little bit later. Thanks.
Thank you, John. Hello, everyone. Austin Malhedo. I'm the other drive and MCC specialist. Thank you, everyone, for your time and attention. So I'm just going to carry on where John left off, but we're going to be talking. My portion is going to be a little bit more on the accessories, some of the power inputs, and also the power topology, excuse me. So let me just get started here. Okay, as you can see on the slide here, so we're going to be talking about the frame A accessories. As you heard John earlier, frame B and C haven't been released yet. I believe frame B is looking to be released sometime later this year. So we'll just kind of get right into it. The The model does, as an accessory, can be ordered with a dynamic braking resistor. You kind of see your two models there, kind of like an external braking resistor that would be attached to the side of the panel, or the other one, which is ending with 6.9 there, built into the side of the Armor PowerFlex. You could also order an I/O guard as well. As you can see the picture, that has a metal logic guard, so it protects your inputs from anything bumping into it, or a plastic splash shield as well, for that food bev kind of environment, right? A single and double-ended shield, a motor, and EM brake cables, which you can see at the bottom there as well as another accessory. Here, I'll talk about the power glands now. So a couple of power gland options. There's only options 2 and 3. When I go to the next slide, you'll see all 3 options. But yeah, option 1, just a conduit or grip cord feed through, up to 1 to 20 horsepower. Option 2 only goes up to 10 horsepower, but it's around M35 feed through connector. That'd be obviously this picture right here. And option 3, the Decina feed through connectors, again, only going up to 1 to 10 horsepower. And then we'll change the slide here. Sorry, it's a little more of an idea. So this would be option 3 would be down here. That's the Decina. Option 2 would be the M35 cable. And then option 1 on the top here would just be the conduit or cord group feed through connectors. And then just showing the 2 different frame types, right? Sean was explaining before. Frame B is, a little larger because it could go up to a higher horsepower, and it's got the heat sink fan there. So again, just showing you the different pictures of your different kind of input power options for both frames. Go to the topology now. So it's just a couple of different power distribution topologies which are supported. Your feed through, which is obviously your top section there, going from device to device, or the trunk and drop. So depending on obviously your setup in your plant would kind of determine kind of what topology we go with. So you have the 2 there, and actually there's a third one as well. It's a hybrid. So as you can see here, you have your trunk and drop. Sorry, your feed through, and then your trunk and drop, right? So, you could do 1 or 2 or the hybrid. So a couple of options there when we're doing our power distribution topology. Going to some of the interfaces on the actual Armor PowerFlex itself. So on the right there where it's marked 1, that would be your 4 user inputs. So your inputs, and then obviously on the safety module, which would be 3, you have your 4 safety inputs and 1 safety output as well. With the option of Ethernet IP, with a dual port gigabit switch, and on option 4, which is an excellent option, you can have an encoder as well, incremental encoder for sine cosine. I'll kind of go over 5 there in the next couple slides. That's a 24-volt auxiliary feed through ports. I'm just going to leave it at that, and then I'll kind of define what that is and what that does in the next couple slides. Just some more functionality. You can see there where the circle with the circled one there, the 3 little dip switches. So that's the one of 5 static addresses. Or of course you can do, like John mentioned earlier, boot P as well. But you could set your last segment of IP with those switches right there. Local or auto mode, along with of course your status lights as well, and local reset indicators as well on the top where it says 4 there, just to give you some status indicators, what's going on. Is there any network issues or line power? Again, just to show you where the power sections are, lockable local disconnect. And then again, of course, I know we went through the power topologies, but where you see 3 and 4 there, you have your little grounding nut there, and lug, and then 3, you have obviously your 3-phase feed through. again, that comes in different options with the different power glands, which was I think 2 slides ago. Next slide, I'm going to talk about that auxiliary power that I mentioned. So there's kind of 2 ways about going about it. You have your with the auxiliary power, which would be the top option there. So you have, of course, your 3-phase power, which would be the 480, and then your 24 DC power supply. So what this allows you to do is you could actually turn the main off, right? You'll cut power to the, you'll lose your motor power essentially, but you'll still be able to see any of your IO functionality, status and information through your SCADA. So it's not like if you turn the power off, you're going to see on your IO tree any of the Armor PowerFlexes drop off, or with the little yellow warning sign. You'll essentially they'll still have power going through the DC bus, which kind of gives you that status and information when the mains are off. The other option would just be an internal power supply. This would be a great option for for the reduced installation costs, because you're not relying on another supply. It's internal. The disadvantage, however, I would say, is if you do turn your mains off, you will not be able to see any of the status or information functionality. So just kind of 2 different flavors of going about it. Next slide is going to be just a little higher level of a diagram of what a topology would look like with a 24 volts power supply. So you have your 24 volt coming into those little 2 auxiliary ports. You can actually even daisy chain them with 2 different Armor PowerFlex, so you don't need a power supply for each. And again, kind of the same functionality. Your 480, you want to do some repairs, or you want to do some programming. You turn the 480 off, but you still have the functionality of your IO and your statuses. That will not turn off. The other slide is just the same thing, but just without the internal power supply, right? So no internal power supply. We're just relying on the 480 volts powering the unit. Obviously, still great. Great for reduced installation costs. The only difference is, of course, if you turn that 480 off, you will not be able to have any status or information or any programming ability until obviously that power is applied again. Okay. I don't know if I mentioned, this comes with 2 gigaports, 2 Ethernet ports as well, so it gives you that DLR functionality. Going to talk about the typical customers that we see who use on machine, specifically the Armor PowerFlex. It would typically be your automotive, transportation, material handling, packaging, and of course food and bev. That's not to say if any of your customers don't fall it under any of these, that there would be no need for an Armor PowerFlex. But typically that's the kind of market we're seeing and the kind of usage we're seeing for the on-machine is the end users, as you see on the screen there. So yeah, again, doesn't mean if you don't fall into these that you can't use an on-machine solution. We're just kind of saying typically this is the use case. And yeah, no, before I kind of dive into questions here, I just wanted to say again, thank you very much. We have kind of 2 different designs that we're leading with here. We have a centralized, obviously, design and the distributed design that John spoke about. By no means are we saying the centralized designs are going away. We have, of course, we sell and support many of these designs with our customers. We just want to kind of give you some options and kind of some just information on, if you have, I know we have some OEMs or integrators on this call, but if you have any customers that in that kind of food, bev, automotive, or if you just see an application that would fit an on-machine solution, we just want to share that distributed design and kind of the benefits that come with that. I think I just want to touch upon as well the motion group. There is a Armor Kinetics as well. So Dave, I don't know if you want to touch upon that later, but in the future, I believe we're going to be sharing some information on that as well. So it's some cool things coming down the pipe when it comes to on-machine solutions. And I just also wanted to add, there is a PowerFlex 750 on-machine solution. Again, it only comes in 480, but if you're looking for that the functionality of a PowerFlex 750. It is offered as an on-machine solution. So if you have any questions, please reach out to, of course, your account managers, John and myself, and we'd be happy to talk and discuss and see kind of which solution best fits the application you're working on. So yeah, I'm gonna open it up to questions, and again, thank you very much for your time.
Awesome. Great work, Austin and John. Thank you for that. Despite the technical difficulties, this was still an awesome webinar. We did record this just to touch upon what Austin mentioned at the end about kinetics, Armor kinetics, is that the Rockwell Servo portfolio is also adding on-machine solutions to their motion stuff. So we will be doing an event about that later on in the year, and yeah, so we'll have more information for you for that in the future. So if there's any questions, feel free to speak up or drop them in chat. We're going to hang out for a few minutes just to make sure if anything does come up, it gets addressed. Again, Austin, John, fantastic job. We're gonna make this video available to all. And yeah, thank you for attending, and we'll hang out for a few minutes if you want to chat. All right. Thank you, everybody.
In terms of might be a customer still hanging around, just definitely make sure you buy a spare for the project. It's even before supply chain issue. This is such a unique part number that's not just sitting on the shelf. In general, I mean, this is a simplified version of release. You get kind of like the two variants, and I think it's just straight up catalog numbers, but it's always good to have spares because it is a specialized device, and if you have a down situation on 1 or 2 units from some lightning strike or something else, you're gonna be needing spares properly on your shelf. So it's good to have that. And maybe even startup spares too, right? It's a good idea. So that'd be my recommendation. You definitely have the efficiency and the ease of putting the system together, but it's important to have spares.